Good afternoon. Again, my name is Brandon Kyer. I appreciate very much that you have given me this opportunity to come and chat with you guys. I kind of want to start with this. Terms like digital transformation and things like that are often overused, and I think in most cases people can't effectively define what it is. This is my definition. I think it's probably, at least from my experience, one of the most accurate definitions out there. I would love if anybody can find a use case of a digital business who's not doing this to bring it to me so I can change my definition. That would be fantastic, but right now I can pretty much lump everybody into that. So the question is, how do you frame this? And I think there are some core questions that we have to ask as we move forward. How effectively is your organization at leveraging data? And I think this is kind of an interesting question, just out of curiosity, and nobody needs to raise their hands or anything. How many people think data is inherently valuable? And the answer that I get from most people is yes, and I would actually contend that it is not. Data in and of itself is not inherently valuable unless you do something with it. It might be valuable at the time it was created, at the time you've executed a transaction of some sort, and it's an effective record about something, but in and of itself, all it does is prove that a transaction happened. It doesn't have any inherent value at that point in time. So how can you leverage that to start extracting data and actually drive your business model? Do you understand your organization's key initiatives? I see plenty of times where we talk to customers and they're some siloed part of the technology organization is working on a project that is completely out of line with what the rest of the business is trying to do, and they haven't taken the time to find out from any of the business stakeholders, and what I'm doing actually align with where the entity is trying to go. I'll give you a really good example. I met with Sky TV down in New Zealand, and there was an individual there who is their chief data scientist, and he was telling me that in 3 months, I'll be able to figure out exactly who's on the other side of the television while they're watching TV. Okay, fantastic. So what? What are you going to do with it? Well, I'll know who's on the other side of the TV. Okay, great. What are you going to do with it? Well, I'll just know. Well, just knowing doesn't do anything. So when I ask the question, can you do things like insert your own commercials into your telecast to sell that as a potential value? Can you do that? No, that's illegal where we are. Okay. Are you going to use it to better work with the advertisers on Sky TV to create better commercials for better times? No, a completely different department does that. Okay, so why are you working on this? Like, there's no value and it doesn't drive their organization or entity forward. So this notion of understanding your organization's key initiatives is one of the most important things that you can probably do. How do you prioritize those opportunities? There is the one thing that is abundantly clear in today's environment with the technologies that are emerging, whether it's AI, machine learning, blockchain, mechs and mods, pick whatever it is that you think is important. The one thing we do not lack are use cases. They're everywhere. The question is, where do you start and which ones are most important to your business and how do you prioritize those initiatives? That becomes one of the most important things. Most organizations tend to hear about initiatives that have huge, huge business value, and everybody wants to go tackle those, and they end up failing. And nobody can explain why. And there's a myriad of reasons, but data is one of those key drivers. Do you have enough of it? Do you have it in the right levels of granularity, the right levels of frequency to actually solve for a use case over here? If you don't, well, you probably shouldn't start there. These may not have the business value of those, but I can actually absolutely succeed with them. When we think about prioritization of those use cases, my opinion at least is that if it doesn't return an ROI in 6 to 9 months, it's now efficiently a science experiment and not a business process. Do you understand the economic value of data? So while we say data has no inherent value, it's a little bit of a misnomer. It has no inherent value until you get some sort of use out of it. But Data is actually, in my opinion, and in a lot of others, rapidly progressing into this notion that data will, in and of itself, will soon become its own currency. And it's happened in the past. So we think about all of those UPC scanners and everything else we use to board a plane, to do whatever. The company that invented the original devices for that, Procter & Gamble, gave those scanners away to retail chains in exchange for the data. Data's first use as a currency. I'm happy to give you a thing, a good or a service, for no other reason than to get the data back. So, everybody's heard of Las Vegas, I assume? Yes? Yeah. Caesar's Palace, when it went bankrupt, and they were going through the process of distributing its assets and going through the sale to evaluate what was going to the creditors, the judge at the time evaluated the total customer loyalty data that Caesar's Palace as an entity had at being worth approximately $50,000. Caesar's argued this. They actually said, we think it's worth a lot more. So the judge agreed and allowed them to put their data up for auction. Anybody have an idea what it sold for? Just shy of $1 billion. It's $960 million. And it wasn't because the data in and of itself was valuable, it was that additional data set necessary to actually gain and extract a lot better information and create value in other organizations and other entities. So as we think about data, it's this kind of two sides of the same coin. On one hand, in and of itself, it has no value. It just collects dust and takes up power in my data center. But if I use it right and I have a plan and I have a business process that I'm going to solve with it, then it becomes immensely valuable. Do you understand how to create a platform that allows you to exploit it? Right? And I think this is the one that you would expect as Dell EMC to come in and talk about and say, let's talk about the platform piece. We'll get into why I won't here in a little bit, but it is important. So this kind of lays out the framework for how we think about where people are from a maturity perspective. It's a very long title, and we leave it alone because it's also exactly accurate. Everybody does this well. What did I do yesterday? What did I do for all of the yesterdays that I happen to have in a database? We're very good at keeping that. If I can start applying those, some new key initiatives that I'm attempting to achieve through the application of data, how do I start taking those, deriving its economic value, applying it to the data to create insights? This is sort of that next level of maturation. As I become prescriptive, as I have figured this out and it proves to be true often enough, I want to take the human element out of that process. I want the computer to go ahead and say, whatever my action is, go ahead and do. Don't wait for a human being to approve it. Fundamentally, this is that first key step in what most AI does. If I can train it and it proves to be true often enough, I can give it over to the machine and let the machine execute on that decision. Once I go from there, I start getting into this notion of insight monetization. Now let me be clear, this is not the point at which you gain value out of your data. You gain value out of your data down here. This is the point at which you know so much about something, people are willing to pay for what you know. All right? This is what large companies like GE and John Deere and others have done very, very effectively. They know so much about a thing, their customers are willing to pay for that knowledge. And if, at the end of the day, what I know is what people are willing to pay for, then how does that change the nature with which I run my organization? All right. The point here is it starts with the business. What is the business trying to understand? What are we attempting to accomplish? Who are my key stakeholders? What are the decisions that they're actually trying to make in order to affect that initiative? What are the questions they need answers to make effective decisions? What's the data necessary to answer those questions? And lastly, and honestly not least, this is where architecture and technology comes into play. This should be the last question you ask. Your data dictates what architectures you need. Can I do it in SQL? Sometimes the answer is yes. Do I need new technologies? Sometimes the answer is yes. But you can only make that decision once you've sort of gone through this process. Any questions? You guys are very, very quiet. It's unnerving. Okay, so is data big and does it have inherent value? This is really big. And to a lot of organizations and a lot of entities, it's somewhat terrifying. And do any of my tweets actually have value? Arguably, no. I do a lot of retweeting, a lot less actual tweeting. But the bottom line is everybody and every entity and every organization is leaving fingerprints all over the world from how they act and why they act and what they do. So the notion here is that while these numbers, again, are all very, very big, billions and billions of connected devices and people, it's not about the big. All that large amount of data is there for is to help you focus in on the small. What are the affiliations of that specific wind turbine? What is its behaviors? How does it react to wind? How does it react to inclement weather? Does it spin as fast as the one next to it? If not, why not? Is a human being any different than a wind turbine? No. We all exhibit the exact same traits. We all respond to certain things differently. I respond to traffic in a different way than my wife. I usually yell at the people in front of me inside my own car. My wife likes to honk the horn. Everybody responds slightly differently. How you choose to interface with my wife versus me will always be different. But how do you know? What are you trying to accomplish? How do you go about doing that? This is where this notion of digital twins comes into place. And if you've looked, Gartner has actually stated that this is one of the top 10 strategic technology initiatives for 2018, and again, they've repeated it in 2019. And the reason is so few people are doing it, and the reality is it's so much more powerful than just this notion of collecting data and doing broad analytics. If you think about things like OptiChannel, how do you optimize your communication with me? And again, is it going to be different than my colleague Waleed? He lives here in Dubai. I live in Denver, Colorado. I probably won't be interested in a coupon for a shop just down the street. Waleed certainly will. But we both work for the same company, and how would you know the difference? And how would you know to advertise to us differently? Unless you model us differently. So this is, to me, is my favorite definition of what a digital twin is. And I'll just go ahead and read it. Fundamentally, it is the combination of data and intelligence that represents the structure, context, and behavior of a physical system, key here, of any type, offering an interface that allows one to understand the past and present operations and make predictions about the future. That's the ultimate goal when you start thinking about how you're going to do analytics. When you start thinking about even broad things, some of the smart cities initiatives that have gone on in Dubai. Others that we're working in the city of Hanoi. Traffic on every road is going to be individualized. Traffic on how I use that road is going to be individualized. Where do I get on? Where do I get off? What times a day? Do I have to take my kids to school before I go to work? All of those things come into play as you start to think about how you apply technology and apply data in a way to actually achieve broader business initiatives. And again, it doesn't have to be me. It could be, as you look at self-driving cars and autonomous vehicles, how do they communicate with each other? How do cars operate differently? Do they make different decisions because I bought a card from Ford versus Fiat? Do we know? Not yet. But we'll have to figure that out. How do you take those things into account today as you design your cities and build new roadways? Big initiatives that I've seen around this specifically, in fact, in my home state of Denver, or home state of Colorado in the city of Denver, they have started an initiative through legislation that every road repair or new road laid has to be built specifically with things embedded into the road to enable and aid autonomous vehicles. Things will be embedded in the road to enable LiDAR to better understand where the boundaries of the road are, to be able to communicate with other vehicles. But again, all of this is predicated on that digital twin. Now we talk about it being small in the context of a digital twin around myself, but it can just as easily be a digital twin around metro traffic. Everything can be its own entity, and how you model that becomes an individual thing. Does that make sense? Are there any questions? Because this is all I wanted to talk about, was the notion of digital twinning. I could go on about a bunch of other crud, but I'm sorry, I heard half that.
Would you collaborate more on the example that you've just mentioned?
The driving?
Yes. Alongside, if you can just explain more in regards to digital twins.
Absolutely. So as we think about this notion of digital twinning, the question is, can I elaborate more on smart cities and autonomous vehicles? So yeah, so the state of Colorado has basically built a command center and a specific group of people to take traffic information, weather information, video camera information from all the intersections where there's cameras, etc. And they're starting to build a physical model based on a historical amount of data on how traffic moves in and around the city, where it goes, what are the most important roads, what are not. They're understanding things like, okay, we know construction is happening on this road and it's made this part of the road congested. Can we predict where people will attempt to go around it? Right? What streets will they turn off early to go around the construction to get where they want to go? And then part of this whole notion of digital twinning is, as they're monitoring that, can they make predictions? So they're constantly iterating through this loop. I know between this street and this street, here's construction. We think traffic is going to reroute onto this street, and this street. Does that prove to be true? No. Okay, it didn't. It was only 2 out of those 3 streets. Why was the 3rd street not used? And then they go through and they take the information that they've got to update that model. So again, it's about this constant prediction of how things will impact whatever that entity is. And this really became important as a concept actually back in the 50s, and NASA pioneered it, because if I have a bunch of people hurtling to the moon and something goes wrong, we can't just step outside and take a look at it. And then it became real popular in the nuclear energy space. Again, you can't just walk into a nuclear reactor and start fiddling with things and see how it works. Fast forward to today, this is going to be a key driver of value for a lot of the organizations and entities that are out there. How well can I model things? And again, it can be very big or very broad. How do I model my customer base? How do I model metro traffic? Down to, how do you drive in the city? Does that make sense? Does that answer your question?